Okay, problem number 11. What do we see over here? Number 11. It's 15x squared minus 11x plus 2. All right, what I'm going to do is use the method that's introduced in this sheet here. And what I'm going to do is take the 15 and multiply the 2 by that and get this, I'm not going to say equivalent, but something that's going to help me factor the problem. So 15 times 2 is 30. Now, once I do that, I can factor this more easily than I can factor the other guy because the coefficient now is 1 in the x squared term. So what I did, I took the 15 and I multiplied by the 2, and I got this over here. All right, now what I'm going to do is factor this thing, and you're going to get x, let's see, x, that's not so bad. And I'm looking at the 30, it looks pretty simple. I mean, I'm going to look at that and say, 5 and 6. You may wonder why that is, because, 5 and 6 multiplied together is 30. But let's just check it out. We do get x squared. We get minus 5, minus 6, minus 11. Works beautifully. Then what do? We're going to put a coefficient of 15 on both of those guys over here. All right, and this seems a little cumbersome to me, but you can do that. 15x minus 6 and 15x minus 5. Again, this is the technique that's being promoted in this section. And I'm going to say, to me, it looks a little cumbersome to do that. All right, but anyway, this is not the factorization problem. Then what they do is say they reduce it. Now, what do you mean by reducing it is looking at each one of these factors and wondering what I could divide through by to make it reduced. Let's take a look at the first one. I'm going to say look at the first one, probably divide through by, well, let's take a look at that. Between 15 and 6, I'd say 3. Now this one over here, I'd say 5. Let me put that down for you. What do you get up there? You get 5x minus 2. And what do you get over there? You would get 3x minus 1. And this would be the factorization of the original problem, by the way. 5x minus 2, 3x minus 1. I can put a box on it indicating it's done. Now, certainly the number of steps involved here was a lot to me anyway. I want to check it. All right, so what's 5x times 3x? 15x squared. Then you're going to get minus 5x, and then you can get minus 6x, and then you can get plus 2. Does that work? It does. You get 15x squared, you get 2 in the end, and internally you get minus 11. It worked out pretty nicely. Again, I believe for some students that may work for them. All right, now the guy, I think his name is Steve Chow, the black pen, red pen guy. He claims that this was a really good technique for him to factor. And you know what? Who am I to judge that? I'm looking at this saying it looks a little cumbersome to me, but when I first saw the AC rule, I said the same thing too. I said, "Oh, that's really a wacky amount of work for something that's simple." So I want to go through the AC method too, by the way. What's the AC method going to be? Well, let me write this down. A is 15, the B is minus 11, and the C is 2. So I write down AC. Well, A times C is easy. It's 30. What I got to do is find two numbers that multiply to 30 and two numbers, when added together, the same two numbers, by the way, would give me minus 11. Well, what am I seeing over there? Well, just like I did before, it's 6 and 5. Minus, minus. All right? Then what I do, I break the polynomial into 4 terms now by taking that middle guy, which is minus 11, and writing down either minus 6x minus 5x plus 2, or if you prefer, 15x squared minus 5x minus 6x plus 2. Both of these are the same as 15x squared minus 11x plus 2. They're both the same. We factor by grouping. On the first, what I'm looking at, 15x squared minus 6x, what would I say there? 3x. We left off 5x minus 2. On the second two terms, I'd actually factor out a minus 1. And we left over there, you'd be left off with 5x minus 2. What factors out from that? 5x minus 2 times 3x minus 1. Are we getting this? We're getting this. Let's put this one over here. Again, if you did this particular grouping, I'd say 5x. What do you get there? 3x minus 1. Over here, I'd factor out minus 2. We get 3x minus 1. What do you get there? 3x minus 1, 5x minus 2. Are we getting the same thing? Well, every single time, we're getting 5x minus 2, 3x minus 1. They're all the same, all right? Now, someone says, which method would you have chosen here? None of the above. What I would have done, looked at the problem, write this down again for you. 15x squared plus 11x, I'm sorry, not plus 11x, minus 11x plus 2. What I would have done is just simple trial and error. And by that, certainly I don't write every try down, but one thing that's nice about this problem over here is I'm looking at the end of it, and it's got to be 2. Now, what I mean 2, it's 2 and 1. If I'm using simple numbers as my only choice, and if we're looking at this over here, I'd have to make a decision now about what to choose. And you're right, this might be more difficult for some students. So someone could say, I think it's 15 and 1. Somebody said, I think it's 3 and 5. By the way, there's not many choices, but I'm looking at this thing, and I really don't see 15 and 1 being at all possible, because from how I arrange those things, I'm never going to get to 11 in the middle. So what I start to realize is that I would concentrate on the 3 and the 5. And then I would look at this thing and I'd say to myself, I wonder what would do that for me. And, looking at it, I don't know. I'm going to say 5x here. But if it doesn't work, I'll try again. And I'm going to say 3x over here. Now, someone says, why are you choosing that? Well, I do see I would get 15x squared. I do see a 2 in the end. And in the middle, I'm seeing, 5 and 6, which is 11. But I got to get these signs right. And I'm starting to realize it's minus, minus. But nonetheless, what I'm going to do, I'm going to check it. 15x squared minus 5x minus 6x plus 2. Do we get what they said we're going to get? We got the 15x squared. Did I get the minus 11x? I got the minus 11x. Did I get the plus 2? I did. All right? So I like to, think about the problem and not do too much writing. All right? But again, it varies from student to students. I've seen students do a tremendous amount of work to get a factorization. As you study more, some students actually use what's called a rational root theorem to look for possible factors in the problem, right? My gut feeling is if there's small numbers, I'll be able to think about it and come up with an answer. Generally speaking, I usually get it in my first try. However, sometimes I have to try maybe 3 times to get it. It does happen. Thank you.